In this video, we're going to look at an integration rule called the constant multiple rule. Now, before I write it down real quick, I'm just going to motivate the topic just by looking at a quick example. Let's say we had the integral of 5x squared dx. Well, at first glance, this kind of looks like the power rule because of the presence of the x squared term right here. But because we have this 5, this coefficient attached to the x squared, technically it's not exactly the power rule because just because we have this 5 here. So what this rule handles is when you have constants that are being multiplied by some more standard function. So here's what we do for the constant multiple rule. If we have the integral of some constant times any generic function dx, then what we can do is we can take the constant and pull it outside the integral, and then we can just integrate whatever the meat of the function is, and then attach the constant at the end. A word I like to use is tag along constant. It just hangs around. So for an example like this, you could pull out the 5, and so you would have basically 5 times the integral of x squared. And so that would be a direct use of the power rule, but having the 5 in there, it's not quite exactly the case. So we'll just do a couple quick examples here. Let's start with that first one, the integral of 5x squared dx. Now we're assuming in this video that you've seen the power rule before because that's what we're going to use here. But in any case, we have a constant multiple of 5 here. So I'm going to pull this 5 out, and then we'll just integrate x squared dx. And this right here is something I actually have a rule for. Is x to the n. I refer back to the power rule, and we have our answer. It would be x to the third over 3 plus c, of course. So what you can do in closing is combine the 5 over 3, pull all the constants to the front, 5/3 x cubed plus c. So we were able to use the power rule after we pulled the 5 out. Now, once you get pretty proficient at this, once you've practiced this, a fair amount, most people usually don't even write this middle step. They'll just look at an expression like this and think, okay, I've got 5x squared. Mentally, I'll just hold on to the 5. The integral of x squared is x cubed over 3 and proceed, just so you're not writing so much. But the first few days that you're learning how to integrate, it's good to write down all the steps, and then you kind of shorten it, the better that you get. All right, a couple of closing comments here. A couple of things you cannot do. If you had the integral of, let's say, like sine 2x, you could not in this situation pull out a 2 because constants inside of a trigonometric function or a square root or a logarithm or something like that, they cannot be factored out because they're not being multiplied to the sine function. The sine function is being applied to the whole expression. So something like this would be a topic for another video. This is not the constant multiple rule. Another example of something we can't do. If you had x squared plus 5 dx or something like that. In an example like this, you could not pull out the plus 5. The reason is being added, not being multiplied. The constant multiple rule says that it's actually being multiplied by whatever your function is here. So we'll finish up with one last example here. Let's say we had the integral of 2x to the 5th minus 7x cubed plus 4 times the square root of x, or something like that. Well then, by the sum and difference rule, we know that we can break this up into 3 separate integrals. And so when we integrate 2x to the 5th, we'll hold on to the 2, we'll take it, put it in our pocket. We'll integrate x to the 5th, which would be x to the 6th over 6. And we'll leave the 2 out front there as that tag along constant. We'll have minus 7 x to the 4th over 4. Again, 7's a tag-along constant. We'll have tag-along constant of 4. This is x to the 1/2 right here. So when you use the power rule, you'd add 1 to the exponent, so it'd be x to the 3/2 divided by 3/2, or we'd rather say times 2/3. That's the same thing, multiplying by a reciprocal, and plus c. And we'll just clean this up and reduce any fractions you can. This will be 1/3 x to the 6th. This will be minus 7/4 x to the 4th, plus 8/3 x to the 3/2 plus c. So this constant multiple rule is very, very helpful because very rarely do you have just a function, just a generic function that you're integrating. Usually it's some multiple of that function, 2x to the 5th, 7x cubed, 4 squared of x, so on and so forth. So it's a rule we use a lot, but fortunately it's not too complicated of a rule. It's relatively simple to use.